start, this was it didn't seem as large as it was going to be. It seemed like it was doable, and I guess it is, but it's on the verge. It's been a lot of work, and it took over a year to get a professor that thought we could actually do it. Dr. Bronner said no like 4 times. So it was about a year and a half before we got Dr. Bronner on board. We definitely learned a lot, I think.
So the circuit is going to go, there's 2 parts, the carrier and the lander. The lander is inside the carrier and it houses the egg. And so this is the circuit for the lander, which is supposed to record all this data and stuff. And right now we got it working, and so I'm putting this liquid tape on there to cover all the bare wires. That way they don't get a short.
Yeah. We took a 1 hour break for lunch, and then it was about one gap where we had about an hour and a half while we were waiting on parts. But other than that, it was straight. At 3 a.m. I was still soldering.
During testing, we had to learn quite a bit about rockets and propulsion and what size motors to use and how much altitude that would get us. And before we ever did any ordering of rocket motors, we had it on paper exactly how many meters we would get. Command Launch Control Officer, arm pad. Launch Control Officer, proceed to countdown, launch.
And we selected arm. We're going to go with 5, 4, 3, 2, 1, ignition.
Right there. All right.
Good job. We got a rocket on stick. We've got a CanSat on stick.
We're good now, we know it.
Yeah! The egg survived.
So about 60 slides, which we put together. We tried to have as many done as we could before we got here to competition. But given that is a report about what happened at competition, you have to do it the night before it is due the next day.
What I liked about it was more of a real world approach, like what a lot of privatized companies such like Apple, Google do, where they design something on paper, then you work through it and you build test phases, and if you meet the requirements of the first phase, you proceed on to the second, third, and fourth, and then you get actually your final real world product. And for us to actually take something that's an abstract idea, and then to make it concrete where we can actually physically touch it.
Trying to blueprint engineer the modulus and different strengths to determine what size of carbon fiber we had, determine what kind of weaves we needed. I was just learning that in the classroom. Like, it's one thing to read it out of a book, like when you read it out of a book, it's just like words on paper, but when you actually apply it at the same time, that it helps your learning process a whole lot better.